Hello, everyone. Thank you for joining us for today's webinar called Leveling Up Cloud Performance. The future of SPARC Emulation has arrived. I am Mariam Khan, and I am a sales director here at Stromasys and the moderator for today's session. Just before we get started, I would like to go over a few housekeeping rules. This webinar is being recorded and will be available on our website after the session ends. And if you have any questions for the panelists, please put them in the Q&A section. And finally, we do have some polling questions, so please be sure to participate. And with that, let's get started and let me introduce you to my colleagues and the panelists. So today we have Paolo Battimello, who is a senior sales director for Southern EMEA region at Stromasys. And Paolo has been with us for over 7 years. And he's joined by Robert Urban, who is a senior support engineer here at Stromasys and a Unix expert. And Robert has been with Stromasys for over 10 years. So thank you for joining us, Paolo and Robert. Let's have a quick look at the agenda and what the panelists will cover today. So Paolo will start off with a brief history of SPARC. He'll cover problems with legacy systems that most legacy owners can relate to. Then we will look at understanding emulation and how does it work. We'll talk about risk mitigation, cost reduction. We'll cover legacy and the cloud. And then Robert will take over and introduce you to our latest version of Charon SSP version 6. And then we will have a conclusion towards the end, and there'll also be some time for questions. So please, as mentioned before, please leave your questions in the Q&A section. So over to you, Paolo.
Thanks, Miriam, for the introduction, and good evening, good afternoon, and good morning to all of you connected today. So let's start with a bit of history about SPARC. SPARC stands for Scalable Processor Architecture. It was developed by Sun Microsystems to run their operative systems, Sun OS, and later the Sun OS that later was replaced by Solaris. It was first presented in 1986, but the first shipment arrived in 1987. And the first shipment was a 32-bit system named SPARC V7. V7 stands for version 7. In 1990, Sun released a V8 version and made a very important decision. Sun decided to make this microprocessor architecture an open technology. So he opened the development to other hardware vendors. As a result of this, in 1993, a SPARC version 9 was released as a result of a SPARC architecture committee led by Sun, but also with the participation of other companies like Fujitsu, like Texas Instruments, and Amdahl, among the others. SPARC has a particularity in the world of legacy. It's a platform that is still sold today. And this adds a further element to the so-called legacy problem. What is the legacy problem? Essentially, the legacy problem is the improving stability and efficiency of the software side of the legacy environment. I mean, application and operative systems become more and more stable, more and more efficient by the years. But this has to be compared to the fact that the hardware becomes less and less reliable by the years. It becomes naturally inclined to the physical breaks down. So you have a legacy problem at this point. And You have to face this problem based on the options that you have. Options. What are the available options? Essentially, there are four options. The first one is the status quo, let's say the doing nothing. And that's not because there is no a problem. That's very much happens because IT department of companies are very often overloaded by daily operational activity, by problem, by urgencies. So planning and executing is always a difficult task. So when we say status quo, we are referring to the delay option. So let's tackle this next quarter, maybe next year. The problem is that the risk doesn't remain the same. The risk grows every day. The risk grows quarter by quarter. So another strategy, possible strategy, can be spare parts. This is a solution that can start reducing the risk, but the problem is that to what extent we can reduce the risk with the spare parts strategy. I mean, if you wait for the breakdown, then you don't have a precise time frame to solve the problem and then go back to production, because you are relying on procuring on demand, and that's always a volatile exercise. But in the legacy space, it's even more volatile and complicated. So you may have another strategy on spare parts, which is stocking the spare parts. But then there is also another problem here, because you cannot be sure if these spare parts will work properly when you're going to need it. And that's particularly when you have stocked these spare parts for a long, long time. So spare parts, it's reducing risk, but there is no way to measure to what extent you have to reduce the risk. Then we have a third option, which is migration. We can migrate the legacy application toward a modern operative systems. This is sometimes possible. Sometimes it's not possible because there is no version for this application on a modern operative systems. For application running on Solaris, we're thinking most of the time to Linux. But even if the project is undertaken, then it's a huge project that have to be considered. In the case of SPARC, we have also an additional migration that is possible. As we said, SPARC is a platform that is sold today. So you may think to migrate to a new SPARC server. But at this point, you have to take a decision about where you want to invest the money for your infrastructure. I mean, you still want to invest in a dedicated infrastructure for Solaris, or you may consider to invest on a new infrastructure, a neutral infrastructure that can host legacy, but can host also modern operative systems. And in this case, even more if you are thinking about the use of cloud for legacy application. And that's exactly where emulation comes in place. And about risk and cost, I would like to make just last point. If you take a look at this slide and all the elements listed on the left side, then one important concept about emulation is that legacy emulation can reduce risk and cost to, let's say, a measurable metrics, which is the same metrics that you can apply building a new infrastructure, or even more, the same metrics that you can apply using and dismissing cloud resources. And that's because the way emulation works. And emulation works in a very simple way. On the left, you can see a traditionally legacy environment. Here we are talking about SPARC emulation for Solaris. So think about SPARC server running a Solaris instance that in turn is running a database and an application. Then on the right side, you can see an x86 layer with a Linux layer on top of this And on top of the Linux layer, our Charon SSP solution for running Solaris exactly the same way you're running on your SPARC server today. So the key point here is that the entire BlueStack operative system database application can be easily migrated on the SPARC emulated server with Charon. And you don't need to change anything in the database and in the application configuration. So we are talking about a minimal impact, a minimal transformation, but a minimal transformation that can have a huge positive impact on risks and cost. On risks, for example, first of all, you completely eliminate the obsolescence problem. The second thing you have to consider is that moving the legacy environment within the x86 environment, then you can use the same security and network technology, strategies, and policies that you have designed for building your modern infrastructure. And even more, you can bring the entire infrastructure under just one management. And this means a much higher level of efficiency. And if we achieve a much higher level of efficiency, then it's very likely that we can also reduce costs. And cost in a legacy emulation project can be reduced on several areas. You see most of these listed here in this slide, but I would like to share with you a piece of data that comes from one of our customers, a large customer based in Europe that have undertaken a project with us on emulation for the past few years. So they were able to measure energy cost for single server. And they were able to give us this piece of data that for an emulated server with Charon would cost them 147 euro per year, which is 160 US dollar. So 137 euro per year, 160 US dollars. At the same time, a recent medium SPARC server, we have to consider something about 5-6 years, medium something around 8 CPU. So a recent medium SPARC server would cost them 295 euros per year, which is around 320 US dollars. So 295 euros per year, 320 US dollars. Even more significant is the savings on a very old SPARC server, where we are thinking about 15, 20 years old. Then a medium SPARC server would cost them 725 euros per year, which is about 800 euros. So the energy savings can be very, very important in a legacy project, a legacy emulation project. But you have to consider that, for example, if you decided to migrate your legacy application in cloud, there are costs that you can completely eliminate. For example, clustering cost, backup cost. These are costs that in cloud you can eliminate by using the functionality of the cloud platform. And that's the reason why cloud is so important today in the legacy emulation business. And this is a survey coming from Flexera, very recent survey, just released a few weeks ago. One important element from this slide is that 89% of the customer has a multi-cloud strategy. And that's also what Stromozy has. We have tested and certified our Charon SSP on all the major cloud platforms. And we have done even something more of this. We have produced a specific documentation for each of these main cloud platforms. And that's very, very important because this helps a lot in bringing the legacy application in cloud. Always from the Flexer survey. As you can see, these are the main concerns customers have when they have to migrate application to the cloud. Understanding the app dependency, assessing the cost, the technical feasibility, right sizing, and selecting the best instances, for example. And these are all things that Stromasis can help you with our tools and with our experience, and making easing the transition of legacy application in cloud. And that's also the reason why our engineering has focused particularly intense on developing for virtual environment and for cloud environment.
Okay, so moving on to Robert. Hi, Robert, if you would like to.
Right, I'm just giving a few more seconds for people to answer the poll question. Hello, my name is Robert Urban. I'm a senior support engineer at Stromasis and a Unix specialist. I'd like to introduce you to Charon SSP version 6 in this webinar. This is a list in front of you of the main new features and improvements. It's not a complete list, but it's the main ones. To give you an idea of the work that has gone into version 6, which is substantial, as I think you will also see. MMU pass-through, I'm going to talk about that in later slides, so won't talk about it here. CMT CPU presentation allows the emulator to prevent emulated CPUs such that they appear to be hardware threads, thus imitating the way real modern SPARC CPU threads are presented to Solaris. Previously, in previous versions of the emulator, each emulated CPU was always presented as a single SPARC core. This was a problem for some licensing scenarios for applications. So in order to satisfy the licensing requirements of some software, this was added. It doesn't have any effect on performance or anything else. It's just the way the CPUs are presented. Support for FMAF instruction, that's fused, multiply, add for floating point. This is adding a new the FMAF instruction to the 4U emulator, which some Solaris applications use. It's not very many, but if you need it and you don't have it, it's a problem. So this is new to 4U. It has always been available in 4V Model T4. The high quality clock source provides a more exact clock for the guest in many cases. This is sometimes it's needed, mostly it's not needed. It's controlled by a configuration parameter that allows selecting this or using the Linux clock source. The snapshot function replaces the suspend function. It will pause the guest, make a snapshot of the VDisks, memory configuration, and then resumes normal operation immediately after the snapshot is completed. Later, this snapshot can be restarted at the snapshot point, which I guess is the definition of snapshot. The new power option automatic is an improvement on the balanced setting. I won't go into details. It's all in the documentation if you're interested. And then we have a bunch of other bug fixes and improvements. I'm not going to go into each of them individually here. Next slide, please. So I'd like to go into more detail regarding the MMU pass-through feature, as it's the most important new feature in my view, because it has an immense performance improvement, really. I'll cover the purpose, how it works, what it provides, the requirements to be able to use it, and traps to avoid. Next slide, please. So the MMU pass-through feature optimizes the guest's access to memory such that memory operations require no intervention. This is significant because it means the memory is mapped directly from the Solaris guest through to the underlying memory of the emulator host. It does require a custom kernel driver that is provided by Stromasis. It can provide an performance improvement of 10 to 40%. I am intentionally vague here because it really depends on the workload. So it has to be tested on a particular workload, but it will almost certainly provide a significant performance improvement. Question is how much. Not yet, please. I'm not done with that slide.
No.
Please go back. For some of you who are familiar with SSP Plus, you're probably asking what the difference is. It's quite simple. SSP Plus is designed only to work on physical hardware. It requires direct access to the underlying processors, whereas MMU pass-through, which has a similar performance impact or improvement to SSP Plus, runs in virtual environments, which means most clouds and VMware. So it gives you that performance improvement without the requirement of physical hardware, aka bare metal. So this is really a big piece of news. So next slide, please. As I said, the MMU pass-through feature requires a kernel module that is provided by Stromisys for specific kernel versions. And I'll go into that more later. 5-level paging is not supported. This is normally not a problem because you only need 5-level paging on a system that has more than 64 terabytes of memory. So, which makes no sense for an emulator, because what would you do with all that memory? So it's not really a problem. You just have to, it's something to pay attention to. Hyperthreading requires, if hyperthreading is enabled on the underlying emulator host, then that has to be addressed carefully. So next slide, please. Some traps to avoid. Because, as I said, hyperthreading requires some manual intervention. It does mean that you have to go to a little more trouble configuring the emulator if you have hyperthreading. You need to use CPU pinning to bind the emulator threads to specific host cores. This ensures that only one emulator thread will run on each host core, as opposed to using both hyperthreads. We really recommend disabling hyperthreading, which can be done in most clouds. Most people don't know this, but you can disable hyperthreading in clouds and on VMware as well. As I also said, MMU pass-through requires a custom kernel module, which means that updates require planning because you must always update to a supported kernel version. You can't simply take the updates as they come from the repository, which would quite likely put you on a kernel version for which there is no kernel driver from Stromisys. The consequence of this is that you should probably deploy the emulator host in a secure network in order to deal with the risk of not necessarily having the most current kernel version running. But I mean, this is a general recommendation for such things anyhow, so it's not really that much of a doesn't make that much of a difference. So that was all for me. If you have questions, please ask them at the end, and thank you for your attention.
Okay, thanks, Rob, for his introduction to SSP 6 version. Just to finish the presentation part of the webinar, we would like to remember two things. First one is that when you look at a legacy project, there are three things that you have to consider: risk, cost, time. The risk to assess, the cost to analyze, and the time to consider for future use. And the last thing that we would like to remember is that today we have spoken about SPARC emulation for Solaris, but the Charon solution family also include the PR risk emulation for MPE and HPUX, Alpha server emulation for 364 and VMS, VAX emulation for VMS, and PDP 11 for RSX 11 for emulation. So that's it, Miriam, back to you.
Okay, thank you, Paolo and Robert. We do have a couple of questions. Let me take, well, the first one. What are the SPARC platforms supported? So what Spark platforms are supported? Is the question.
Okay, I'll take that.
Thanks.
It depends on
Yeah.
the emulator. The 4M emulator emulates the SPARC Station 20. The 4U emulator emulates the Enterprise 450. And the 4V emulator, you have a choice of two platforms, the T2 or the T4. However, I should point out that the platform is not really important because you can migrate Solaris from one supported platform to another without much trouble. So these are the most popular, the emulated platforms are the most popular platforms that have the widest support for Solaris, which is really the important thing.
Okay, thank you, Robert. Thank you.
You're welcome.
Paolo, there's a question I think is very interesting, and perhaps we should elaborate on that. One member of the audience asked, what does SSP mean in Charon SSP? Would you like to take this, please?
All right. SPARC Solaris platform.
Okay.
I hope it's clear. SPARC Solaris platform. Charon SPARC Solaris platform.
Yeah. It's just how we name our products, Charon, and this is the SunSpark emulator. We just make it more interesting by giving it three letters.
Yeah, but they are right, because we give a lot of things for granted while they are not.
Absolutely. Okay, thank you, Paolo. Well, we've got another interesting question about which versions of OpenVMS supports for the cloud. So, Robert, if you'd like to. Yes.
Unclear what is meant by that. Let's skip that and move to the next. I see a question, any alpha version supported by the same person, so maybe we should address that instead.
Yes, please, go ahead.
Unclear what you mean by alpha, maybe VMS. I think we support VMS. Well, we have a VAX emulator and an alpha emulator, and we run, I think, down to version 5 VMS on the VAX, and then VMS, whatever the last alpha VMS version was, it supports alpha 8.4, I think, and all the previous versions of VMS that run on the alpha we support on the alpha emulator.
I can add that, if I remember well, but I think I remember well, our ever first customer in cloud was OpenVMS. I don't remember the version at all, but I remember that our first customer in cloud was all for migration of application running on OpenVMS.
Okay, thank you both. We have a couple of more questions, so let me pick another one. If I am staying on bare metal, can MMU pass-through be disabled for a given guest? So Robert, back to you.
I'm trying to understand it. Well, typically, the one emulator instance is run on a dedicated emulator host. So so you can turn on an turn on and off MMU pass-through in the emulator configuration. So if you were to run multiple emulator instances on the same host, you could turn MMU pass-through on one or enable it on one and leave it disabled on another instance on the same host. However, this would require a certain amount of manual configuration in order to keep the emulators from competing for the CPU resources. So that it would require some CPU pinning in both cases. But in principle, yes, you can have one with MMU pass-through and another without running on the same host.
Okay, thank you. Perhaps one for Paolo. So one of the audience member asks, we have premium support. Will this Stromasys version update? Where will I steps to update version? have new license require after Stromasys emulator software update? So I believe they're asking they have platinum support, and how will they be able to access this updated version?
I think this is something that is going to be communicated in the next couple of weeks, something like this, 2 or 3 weeks. It's on process of to be defined. So stay tuned the next weeks.
Indeed, we will send out a communication about this.
Yeah.
Officially. Yes. Okay, thank you, Paulo. Robert, a few more for you. I think we still have some time, so this is interesting. Okay, so one member asks, does Charon SSP run like hypervisor on Linux OS? If so, is there a web interface to manage Charon SSP like a hypervisor?
It can be compared to a hypervisor, yes. It's a software. It's an application that runs in principle. It's like any other application that runs. It's multi-threaded, but it's not. In various important ways it differs from a hypervisor, but it presents an emulated / virtualized, in this case, SPARC platform to the guest operating system, which is running within the emulator, let's say. So it has many things in common with a hypervisor, but it's not really a hypervisor. And the second part of the question is there is no web interface, but there is a graphical user interface called Charon Manager, which can be used to manage and operate SSP instances, to configure them and start and stop them and create them and so forth.
Okay, thank you. We've got many more, which is interesting. So one member of the audience asks, is there any future roadmap plans to help improve the CPU overhead?
I presume that means improve performance.
Yes.
Reduce CPU overhead. So, the answer is we're always working on performance. We're always trying to improve the performance of the emulator. However, it's important to realize that emulation is a costly task. It is really hard because you're translating one instruction set architecture stream into another instruction set architecture stream. And we have various techniques. We've developed various techniques to improve this. For example, translating blocks of legacy instruction set code and then caching them, and then recognizing when we are re-entering such a block and then going to the cached translated block so that we don't have to retranslate everything. So yes, the answer is we are always trying to improve performance. I don't think we publish a roadmap on what we're currently working on, but we're always working on it.
Hey, thank you. So there seems to be a few more questions about Solaris. So one member asks, do we need to lift and shift the applications running on Solaris systems if we were using the emulator?
I guess that's to me again.
Yes.
In principle, no. The general process for migrating is that the same process for migrating from one SPARC platform to another SPARC platform, because in really the emulator is just another SPARC platform. It happens to be implemented in software, but for the purposes of migrating or from the way it's presented to Solaris, it's just another SPARC platform. So unless you have particular needs and you need to split up the workload for some reason, you lift and shift Solaris and everything on top of Solaris from the from the hardware SPARC platform to the emulated SPARC platform with minimal changes. No changes to the applications, a few customizations are required for on the Solaris side, because usually the platform details are a little bit different, and the disk names change, for example, or the NIC names. But in general, it's just one huge unit that gets lifted and shifted.
Okay.
Yeah, I can add one thing to this point. Most of our customer wants to migrate in a lift and shift mode. Some other customer also take the opportunity of a legacy emulation project to do consolidation, to rearrange the environment in a way to also saving money in terms of infrastructure needed. So can be both ways.
Okay. Thank you again. Well, I think we have time for perhaps two more questions. Paolo, there's perhaps one for you also here. Somebody asks, are there any plans to extend Charon SSP to support the Itanium architecture? I think they mean to, maybe not Charon SSP, but yes.
No, maybe if they refer to SPARC Solaris, thinking about SPARC for x86, no, I don't
No,
think.
the question is there an
No.
Itanium emulator? That's
Yeah, I think that's what they meant. Yeah.
If it's out Itanium for PR risk, then it's something that we have been considering, yes. And if the customer wants to have a little bit more information, they can contact us and we can analyze their environment, because at the moment we have also some kind of solution, not directly emulation, but some kind of solution that can be of interest for a customer running an Itanium server.
HPUX on Itanium.
Yeah, HPUX on Itanium. Yeah.
Okay, I suppose we have time for one last question. And if there's any unanswered questions, please do reach out to us. We have your name, so we will try to get back to you personally on those. So let's take a cloud-related one. Right. So someone asks, few banks use SPARC in Solaris platform with core develop in COBIS. They use mostly the development ambient just to run testing and stressing the apps. Is it possible to use Charon to do this in any cloud? So I assume, Robert, it's again for you.
I can take it. Yeah, I'm not very familiar with COBIS, but it doesn't really matter, because I presume it's some sort of application, and because we're emulating at the hardware level and on which Solaris runs, and then the applications run on top of Solaris, it doesn't really matter what the application is that's running on Solaris. It'll run. There may be performance considerations because emulation does have its limits, but we certainly have a lot of customers that are using emulated systems to perform all sorts of tasks, including testing, but also running production, depending on their performance requirements, and really anything that, I mean, we have customers in every imaginable segment, finance, aerospace, what have you. So I'm sure it's possible to use Charon to do this. I wouldn't say in any cloud, but in the major clouds. We support Azure, AWS, Google Cloud, and OCI, Oracle Cloud infrastructure, and maybe a couple others. I'm not sure exactly which ones, but the major ones we certainly support. So if that's your definition of any cloud, then yes.
Okay, thank you, Robert. Actually, we do still have a few more minutes. So I think just to add to Robert's point, yes, we are partners with all major cloud providers. So if you have any specific questions about any specific cloud provider, please do reach out. Right. Okay. So seems like one last one, perhaps. Let's take. I saw a question about alphas. I'm not sure, Robert, if you answered that already. Any alpha versions supported? Maybe let's tell them a little bit more about. Oh, we did.
I think I did.
Oh,
Yeah, that was, we assume VMS was meant there.
Right. Okay. Yes, there was two questions. Okay, so someone asks, is it possible to emulate Solaris, maybe using T4 platform and treat it as a global zone so that it can run local zones as it maybe would if it were a physical server?
The answer to that is yes. Zones are implemented with Solaris, and Solaris runs on the emulator. So you can create zones and administer them as you have done in the past on the emulator. It's no different than any other SPARC hardware in this case, and you have the choice in. You're talking about the 4V architecture here, the Sun 4V architecture. So you have the choice of the T2 or the T4 model. So yes.
Okay, great. Well, I think that's all the time that we have. We have a lot more questions, but like I said, we will try to get back to you individually on those. Due to time constraints, we would have to wrap it up.
I see one more question. Do you mind if I
Sure.
just answer that?
No, please go ahead.
It's one of our participants asks, most of the app license in SPARC hardware are core based. How app license managed by emulator? So software licensing can be bound to many things, including things like the MAC address or the host ID, which is unique to the SPARC system, I believe. Well, at least it's one of the things that application licenses often use. But it also can look at the cores or the threads in the cores, and actually that was a new feature that I talked about, which is new in version 6 of SSP, which allows the emulated CPUs to be presented as hardware threads, so that licensing requirements can more easily be met. So I hope that answers your question.
So thank you again, everyone, for attending, and we certainly look forward to seeing you at our next event. Have a great rest of your day. Thank you.
Thanks everyone for attending.